Hello, good evening. Um, so before we start, we look at what we learned last week first. I just state the important point. So factor that affect the stiffness of the string. There is 4 factor, right? Including the arrangement, it will be 5 factor. So first one, it is length of the string. The longer the string, the less stiff the spring. The diameter of the spring, diameter of the coil. Okay. So the bigger the diameter, the less stiff the string. Okay. Now the third factor, it is the thickness of the wire, right? Thickness of the string, thickness of the wire, big diameter of the wire. So the bigger the diameter, the more stiff the spring. The more stiff means higher the K, higher the spring constant. Lastly, it is the material to make the spring. Okay, material to make the spring. The iron compared to steel, iron is more stiff, right? Compared to iron. All right. Lastly, it is the arrangement. So if I arrange in this way, so it is more stiff, right? Arrange in parallel, it is more stiff. So the calculation. So when you do the calculation, so you are using two formula. F is equal to kx Hooke law, and energy stored in the string, energy is equal to half fx or half kx squared. Make sure if they are asking you the energy letter, if they ask you the energy, so this K must be Newton per meter. Alright, so you have to use Newton per meter so that your answer will be in joule. Right? So if this one, right, they don't ask you about the energy, so you can use Newton per cm, the calculation. So make sure you know how to use it. Okay, now before we continue, so I want to announce, so this is our last lesson for free class, right? So start from next month, there will be no free class. All right. If your friend want to join, ask your friend to join fast, and then ask them to fill the referral. All right, referral fill under your name. Please remember. Okay. So there is a lot of question that I didn't do, right? So I try to skip some before we move, right? I'll try to skip some lah. All right. If you are not sure, you can just ask me. Um, why do I skip? Because of there is too much. If today I do all the question, then I don't think I can start chapter 2. All right. And then I think we just go for the uh structural question. All right, structural question or essay question. Okay. We do some. All right. Um. Okay, we start from page 143. Page 143. Yeah. So now we look at the question. Diagram 10.1 show a spring that is thick and has an elastic property compressed. When the metal ball is pressed onto the spring with a force. So B 10.2b, right? B shows a maximum height reached by the metal ball when the hand is released. So you compress and then you let go. So what is mean by elasticity? Elasticity is ability of the spring to return back to the original size and shape when the force or when the load also can, when the force applied is removed. Okay, Now, based on 10.1 A and B, explain how the metal ball can reach the maximum height. Okay, so how can the ball reach the maximum height? So you want it to reach the maximum height, right? So you have to go for maximum height. You have to go for kinetic energy is 0, half mv square. Alright, so this one it is maximum, right? So maximum kinetic energy, so that you will get the maximum height. So your energy must be maximum. Okay, you need to know your energy have to maximum. So if you want to have this one maximum kinetic energy, so now you gotta have the energy stored in the string, it is half kx square, right? So your k must be higher and your x must be higher, so that it can reach the maximum height. So k, because of this spring already fixed, so the k I cannot change. So impossible that I change a better higher k, change the stiffer spring. So I don't want to change it. So the only one way is x. So increase the x, right? Increase the extension of the string. So now so format here. So first one, increase the extension of the spring. So increase the extension of the string. So increase the extension of the string, you might need to explain why. So to increase the energy stored in the spring. To increase the energy stored in the string, the energy will change to kinetic energy. So the elastic potential energy will turn to kinetic energy when the force applied is removed, right? So when you remove it, right, your force you apply, it is removed it will change to kinetic energy. So now I don't have any point already to put in. So in this case, if you want, you can try to put in the formula, right? Because you don't know what to do. All right, later I'll show you the answer. You don't know what to do. So elastic change to kinetic energy so that it will reach the maximum height. So now in case they want, right? So elastic potential energy of the spring is E is equals to 1 over 2 kx square. Okay, so you just put it in like this. So this is what you have done. All right, so I like your answer. I like your answer. Now here we go to see the answer. Wait, this one is Kelantan 2024. Okay, Kelantan 2024. Kelantan schema paper 2. All right. Okay, so you see now this one is in BM lah. So daya dikenakan terhadap spring yang tebal. So they want, right? They want thick spring. So I don't have it. So where you got it here? Your answer here, right? Force apply to the thick spring. Okay, spring constant higher lah. Another word. So I don't have it. So ketebal spring bertambah, nilai nilai pemala spring bertambah. Mean the the thickness of the spring increase, K increase. Okay. Now, pemalas spring bertambah, daya keupayaan bertambah. So, EP is half Kx squared or half elastic potential energy is half Kx squared or EP is half Fx. Laju dan tinggi bertambah. So, I don't have all. I got this one and this one only. I got 2 mark only. Right? So, the height, you can reach the maximum height. Right? So, increase the extension. So, I don't have it. So, what should I do? I use the answer. Wait. So they want to, the one that I want is just now. What I explained is energy is equal to half Kx squared. So I said these two, the spring, it is the same. You don't want to change, but they want to change for this case. So now you cannot increase the extension only. So my answer, it is not given in the answer. So use a thicker spring. So why use a thicker spring? Thicker spring or bigger diameter, a bigger diameter of the wire also can. Thicker spring has a higher spring constant. So thicker spring has a higher spring constant when nilai pemala bertambah, ya. Yeah, correct. Thicker spring, then higher spring constant. Yeah, these two are the same. Okay. So pemalas spring bertambah. Okay. When the K increase, when the spring constant increase, when the spring constant increase, the elastic potential energy increase. So lastly, right, so you can reach the higher point. So where I got it, and then the formula put in, yeah, I got it. So I only got, it will reach the maximum height, 1 mark. And then elastic potential of the string is half Kx squared. So I got 2 marks. So this question, 4 mark, I told you, you must able to get 2 marks. Right? In SPM, if you able to get 2 marks, you got chance to get A. Alright? Okay. Now we continue from here. Table 10 shows the characteristic of the spring used in a pen. Length of the spring 2, 4. Red or rusting. So red or rusting, whether it can get rust or not, right? So must be low, right? Must be low. Low mean it will not get rust. High mean easy to get rust. So I want this one. So obvious is this one. So I need to see whether it is short or long. So material, iron and steel. Steel, it is stiff. Iron, it is less stiff. Thickness. Thickness low. Thickness of the wire low. Both are low. So in this case, I only can choose, but I want to choose steel. So this one I have to use long, right? Because of steel. But for me, iron also can, because inside your pen, right? Inside your pen, you are not going to reach the water, right? Your pen, you not kena water, right? So it will not easily kena water. So when it is not kena water, so should be not a big deal, right? Not a big deal. But this one it is better, right? So still, so I want to choose this. So now here, now you are required to study the characteristic of the spring and then explain the suitability of each character of those spring. That means the spring that can use to remove the pen nibs more easily. Give the reason. Okay. So what you need to do is, if you don't know how to do this kind of question, so you must use characteristics, build a table, right, and reason. Okay, build a table. Okay, first one. So normally you go length of the string, cannot write number, so you just write longer spring, longer spring, right? So the reduce the reduce the spring constant. So why you need to reduce spring constant? Reduce the spring constant to press the pen easily. Alright, you can press it easily. Right, can press easily. Now don't write this. I see some of you write this. Right, you are writing increase elasticity. So mean you use the shorter, it is not elastic. What you say? So what is elastic? So you elastic. So I don't care long or short, it is elastic already. Okay, don't say increase the elasticity, so more elastic. No, right, nothing to do with it. Okay, now second one, it is, so I want to use low rate of rusting. Low rate of rusting. So can last long, right? It will not rust easily, right? You can write not rust easily. Okay, can last long. Now the material it is steel. Material steel. So why are you using steel? Low rate of rusting. Alright, higher spring constant. But here I write low spring constant. Strong or not break easily also can, right? So lastly, thickness of the wire is low, right? Thickness of wire low, right? Why it is low? Reduce the spring constant. Lower. No. Thickness of the wire reduce the spring constant. Right? So now the best answer will be U. Right? I want to choose U. U is the best. Best what? Best spring. Best spring. Because you continue. Right? Long spring. The spring is long. Just repeat this one. Low rate of rusting. Steel as the material and low thickness of wire. Right, this is how you're gonna answer. Right, so put this one into the table. Right, this one, right, you can draw. Next time I'm not going to draw the table here, so I hope you can do the table here like this. Put it into table. Okay, You put it into the table lah. All right. So we see the answer. We see the answer. Dawai besar tinggi. Alright. Pemalas spring kecil. Right. Spring constant small. Daya kecil dikenakan. Can press easily. Lembut kenyal. Alright. And then kadar pengaratan it is rendah. Rate of rusting it is low. Why? So tidak berkarat. Tahan lama. Okay. Keluli tahan tidak berkarat. You just repeat lah. So tahan lasak, right? Can last long. Right? These two can repeat the same one. Right? Thickness is low. Right? Lembut. Right? K is small. K is small. The spring constant is small. Or U, and then you just repeat. Okay. So this is how you're gonna answer this. Right? So where you answer here, here it is quite okay. Right? I like your answer. And then one thing is you want to write here, so you just write I don't like this less stiff, and then you said less stiffer or less stiffer, so like not so correct. So you don't use the word less stiffer, right? Less stiff, right? Or you just put less stiff lah. Don't use the word less stiffer. This word it is like less and then stiffer, so quite confusing. All right, don't use the word less stiffer. So you just said less stiff, right? Will be okay. Or less, the K it is less. Okay. Now your answer is quite okay. All right. So okay. Now continue from here. 10.4 shows the spring with the original length 15, and then 12, and then 5. You put P, become 12. You put 10 kg, become 5. Calculate the spring constant. Alright, so number 1, we are going to calculate F is equal to Kx. Alright, F is Kx. F 10 kg. 10 kg. Normally, this one we are going to use the gravity as 10. 10 times 10. Right? mg. Right? We take gravity as 10. Right? So if you want to use the 9.81, also can. Right? 9.81. Right? mg. K, don't know. X, extension of the string is. Now, you see here whether are they asking you the energy. If no, then you use X as cm will be okay. Right? X in cm also okay. So this one to here will be 10 cm. So cancel the 10, cancel the 10. K is 9.81. So this one is unit is Newton per cm. Okay. So the first one done already. So second one, they are asking you the mass of the P. Mass of the P. F is equal to Kx. So F, now F it is, I don't know. P is M times G. Right? M times G is equals to P. So K is here. 9.81. And then X, extension is 15 to 12. It is 3. Right? So now G it is 10, right? 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 The mass. Right? Mass time 9.81. Okay. Never mind. Sorry. 9.81. So now here. So the mass is equals to, so I cancel, left 3. 3 kg. Right, 3 kg. So this one is 3 kg. We see the answer here. Right, so it is 3 kg. Here 9.81. So they use Newton per meter also can. No worry, because this one they don't ask energy. Right, so it is okay. Right, but the one that you have done here got a small mistake here. Now here Now you calculate the P. P is this one, right? So 29.43 Newton. But they want mass. Mass must be in kg. Alright, so you need to change it to kg lah. So you see, 1 tick, 2 tick, 3 tick, 4 tick. 4 tick is mean 4 mark. So this one is 5 mark. So you see, 1 tick represent 1 mark. Huh? So you short of 1 mark. You didn't change it back to kg. So I changed it to kg. Alright. Okay. So I try to pick up some more question to do it. I'm not going to do all. Right? I try to see whether the question that you are not really sure how to do, like this one. Okay, this one we can discuss. This one. Okay, now this one is more important, right? Pahang. This part. This part is important. Okay. Now, okay. I want to do it within half hour. Yeah. Terengganu. I see your Terengganu okay or not? Right. I just pick some because not many of you pass up. Right. Just 2 of you pass up. So, right, this one is quite okay, ma. Right. So I'm not going to discuss. It is quite easy to answer. So this one is quite okay. Right. 1, 2, 3, 4. Okay. Right. Just this one. Okay. So I read E. I do E. I do E. So other I skip. So if you pass it up, then I'll mark for you. I do E. I do E for you. So diagram 11.3 shows a cuddle, right? Used to put the baby to sleep. This is a cuddle frame. So you are required to give a suggestion to improve the design of the cuddle so that it can be accommodate a larger baby. Explain the recommendation based on the characteristic of the spring, characteristic of the cuddle frame so that it is safer and easier to use. Okay. So this one is quite little. So we are going to put in here E. So here also the same, this kind of question, you write characteristic and reason. Okay, now this one they give so little what's that called, information for you. So they just want, right, first thing it is larger baby, mean the mass increase. So mass increase, so you want the K increase. Mass increase, I mean you want to withstand higher force, right? So now higher force, so the only one 3 thing, right? 4 factor, right? 4 factor, so that 4 factor, I think you can use it. Okay, I see what you write here. Higher spring constant, still strong. Okay. Now these three, length of the spring short, the diameter of the spring, it is small, and then thickness of the spring, it is thick. All correct. But this one, for the answer, I will write like you also, but the answer given, it is higher spring constant. These 3, higher spring constant. Right? These 3 stand for higher spring constant. Okay. We look at the answer, right? Faster. Kelantan, right? Kelantan 2023. Kelantan. Schema. Question number 11. Okay. Eh? 2023, correct? Eh? Oh, should be question number 10. Wait ah. 11 eh? Eh? Salah hả? Not this one. Wait ah, 2023. Paper 2. 2024 lah, I guess. Wait ah. Should be 2024. Oh, Terengganu. Terengganu, sorry. Not Kelantan. Terengganu. Terengganu. Schema. This one. Okay. So, they want this one. Number of string more, right? Parallel. String constant higher. You see, they want this one only. They want this one only. Type the string, it is still, you got it. Right here, you got it. This one, you got it. You got it. Type the string, it is still more stiff. Right? So this one is okay. And then elastic limit of the string, it is high. Right? High elastic limit. Alright. And then this is the answer. Right? And then they got many lah. Alright. So I'm gonna put it in here. I screenshot this one for you. This one don't want. Okay. And here. Okay. So this is the answer. More number of string. Number of string increase. So now the string constant is higher. So more number of string, I don't like this kind of question. I don't like this kind of answer. More number of string is in this way ka? Or in this way? Alright, of course it is in this way, right? Should be more number of string arranged in parallel, right? More number of string in parallel. So they said these two, right? So these two, I want you to put together, right? More number of string arranged in parallel. So higher string constant, right? Higher string constant. These two are. You combine this one. Excuse me. Now, string constant high. All right. So this one. Type of the string still. Right. Elastic limit, it is high. Right. This one. Elastic limit, it is high. Mean it is not easily reach. Or the force that you apply, it is not easy more than the elastic limit. What does that mean? Right? Some of you like got a very wrong concept on this one, meaning that this one is F, this one is X. When it is more than this, so I said it will be not go into straight line already, meaning that your spring here. So what I do is I hang 1 kg, it extend. I hang 2 kg, it extend. I hang 100 kg, you. Alright. After you let go the 100, so it become like that. So the spring spoil. The spring spoil already. So it cannot return back to the original size or shape already. It is not elastic no more. It will not elastic anymore. Okay, you need to be very, very careful on this one. Alright. Okay, so higher elastic limit. Alright, so you will not reach the elastic limit easily. Alright, it can withstand more force. Also can. So size of the frame it is big, so more stable. So where is size of the frame it is big? Here, size of the frame, right? Cattle frame. So this one it is big, so that the bottom it is big, so it is stable, right? Stable, huh? And then the material it is still very good, right? Material of the frame, alright, it is steel, so can not rust easily. And then strong frame, so not break easily. Okay, this is the answer. Is that okay? So how much you get? Right, 1, 2, 3, 4. Right, 4 mark only out of 10 mark. So this one sayang. Right, these 3 I write here already. Yeah. You ask me one question, normally, teacher, this one wrong, but this one correct, right? Less elastic, or more elastic, or more stiffer, or what? So this teacher, this one is correct, so when this one not same, so this one they are not going to mark, right? And then you said short, it is not elastic or less elastic or more elastic, nothing to do with it, right? Shorter or longer, just make it more stiff or less stiff, right? Not make it more elastic and elastic like what I told you just now. Okay, hopefully you can understand. Now this question that I want to discuss also, all right? So this question you are not doing well, so which is 2021 150, yeah. So page 150, we go to page 150. We pick up some to do lah. No? Okay. That this question is, I tell you, it is honestly it is hard, right? So I think I cannot answer it well also if I am sitting for this one, right? Diagram 11.2 shows the graph x against f, x against f, so in the experiment. So the best on the 11.2, set the suitable formula. So you want formula, explain how the spring constant and the elastic potential energy is measured. Okay. Now spring constant. First of all, you want to do spring constant, right? What do you write here is F is kx, right? What you write here, it is okay. So now first one, F is equal to kx, alright? So where you explain a little bit. So k is equals to F over x, where spring constant is not gradient of the graph, right? So oh, okay. Wait, I cross this one first. Gradient. What k is equal to 1? I don't understand this one. Okay, now I tell you. Now, normally you see this. I want you to understand this. So this is f, this is x, right? So the gradient of the graph of fx, right? Because f is equal to kx, right? So y is equal to mx plus 0 plus c, right? C is 0, so plus 0, so y, y, m is your k, spring constant, x is your x-axis, plus 0. Okay, so what is m? Gradient of the graph, right? Gradient of the graph is here, stiffness of the spring. Okay, but this one is not. This one is not. No. So you said gradient of the graph? No. String constant is gradient of the graph? No. So you should have, right? Right? It is 1 over gradient of the graph. Do you understand this? Because you find the gradient is x over f. So I want f over x. So f over x is 1 over the gradient of the graph. Do you get it? Okay. This one, you said the gradient of the graph xf, k is 1. I don't get it. What is this? So this one, no mark. Alright, no mark for me. Now, so the second one is, okay, second one is energy in the spring is E is equals to 1 over 2 k fx, right? Because of you don't have k, right? If you want to have k also can, but I want half times f times x. So now half times f times x is half times f times x. So x is here. So f is here. F is here. X is here. So half times f times x is area under the graph here. Not here. So normally the one that we answer is like, oh, area under the graph. Alright. But this one must be f and x. Area under the graph is your energy store. But this one's supposed to be here. Right? This one's supposed to be here. Okay. So energy store in the string is half fx where it is the area bounded between the line to the y-axis, right? The line to the y-axis, right? Here, this line to the y-axis, and the unit of the extension must be in meter. Okay, so write this one down. Alright, should be okay. Alright, so this is what we have. Pahang 2021. Pahang 2021. Question 11. Question 11, here. We see how do they answer. Okay, here. This is the answer. Mark 1, they said. Right. Mark 1, you write this or this one. Okay, 1 mark. So from the graph x, f, k is equal to 1 over gradient. Right? 1 over gradient. So you got another mark. Area under the graph of xf. Now this one I don't think the answer is how area under the graph xf. But which area? Area where? So normally area we said it is here. You know what I mean? Area under the graph normally it is here. What do we say? It is here. Yeah, area under no. Area normally we say it is here lah. Area under the graph. So you should say here, the area here. Okay, so this one even the answer is here, but I am not agree. Right. Okay, Donna. Right, but their formula is correct. Half times f times x is correct. Okay. All right. Question. Question. All right. Should be okay. All right. Should be okay. So we try to see. I guess we can do one more. Okay. Now, I discussed a bit about this one. Using the knowledge of elasticity suggests a characteristic of the spring which enables it to absorb shock, right, efficiently, right. I want to explain what is absorb shock efficiently. Then explain the suggestion based on the following aspect as the material of the spring, physical condition of the spring. So they give you physical condition, right? Spring constant, rate of damping. Alright, rate of damping. Okay, now what is this? Okay, now absorb shock. So now for example, this is your motorbike. This is your motorbike. So this one is a spring. So now when you pass through a bump, let's say you got a bump here, right? So your motorbike go here, right? Your motorbike go through. So go through. So what happened is you. So what happened to the spring? The spring here will be extend, and then it will like you. So if the K it is higher, so so it is stiff. It is not easily damping. We said damping. It will not vibrate so many times. So K is stiff. Now, if the K it is not, the K it is low, mean it is less stiff. Less stiff, then you. So you are on your motorbike, you feel like you pass through one bump, and then you like dancing there for like 10 minutes, 5 minutes, 2 minutes. You want it? You don't want it. So the K have to be high. The K have to be high. Right? So that's why they said spring constant have to be high. Right? The smaller diameter, okay, they gave you smaller diameter, spring constant high, thick spring, okay. Right? Type of the spring, it is arranged in parallel. Alright, this one all correct, but you write more stiffer that I cancel the fur there. And then the last thing is arrangement of the spring in parallel. How are you going to arrange in parallel? So this one is your shock absorber, right? Shock absorber. And then you arrange two springs parallel together, and then like that. How? No, not logic. So just one spring. So this one it is no, right? Parallel is not in the answer lah, right? So we see how the answer given, right? Answer given. Pahang why that one? Okay, you look at the answer. So spring made from steel will not rust easily. Short spring, okay, can support greater load or smaller compression, smaller diameter, right? High spring constant, thick spring, right? What? And then high spring constant, right? So this one they repeat, right? This one stiffer, this one stiffer, this one stiffer, and then this one stiffer, and then this one also stiffer. Right, so these all they repeat. Now some of you will ask me, Cikgu, just now you said you cannot. Yeah, that's why we don't know when can it be. Right, like sometimes they want it to be in this way, but sometimes they don't. Like just now you see the answer. These three you write it separately, but they don't want it. Right, they want one only, but sometimes they want. So depend. So for me, like what I told you, I also will write this way like what you wrote. So this one, when you write it wrongly, right? This one, they don't have mark. They don't minus your mark. Meaning that this one salah, no mark. This one salah, no mark. This one salah, no mark. But you still write higher spring constant, and then stiffer. So this one got mark. And then you write more space one. You understand what am I saying here? You write more space one, right? So you get extra mark. Is that okay? That's how you answer in SPM, right? Now, of course, you ask me, Cikgu, how can this answer scheme like that answer scheme not same? Like, when do we know which one do we want? So we don't know, because answer scheme is made by the marker, right? Made by them, right? If I make, I got my own answer, right? If you got your own answer. So, but our point will be the same, but we cannot be 100% same answer scheme. That's why we got the different answer here, right? So now here, lastly, spring that higher rate of damping, not higher rate of damping, right? It is low rate of damping. So the amplitude reduce fast, right? This one is wrong, This one is wrong, right? This one, low rate of damping. I give the answer here. Wait, like that. This one helped me to change. Oh, no. The answer is here. So, low rate of damping. Low rate. You don't want it to damp so long time. So low. Low. This one helped me to change. Enough. Okay. We still got so many. Right. Okay. What is spring constant? Spring constant is, now you can write in F is equals to Kx. What is K? They are asking you what is K. F and over X. So the force needed to produce 1 unit of extension. Right? Expansion or string. Expansion or extension also can. Right? Same. Okay. This one should be okay. The one that okay. Now this one is the one that I want to discuss with you. Right? You try to have a look. Now, I don't care how do the question ask. The greater the spring constant, the more thick the string. Or I got 2 strings. One is thin, one is thick. This one is thick. This one is thin. Okay. What does that mean? The higher the string constant, then the spring will getting thick. Or the thicker the spring, the higher the string constant. Which one is correct? So you have to write the thicker the string, the higher the spring constant, the greater the spring constant. So this one you write terbalik. This one cannot terbalik. You must know. Okay. The thicker the string, the smaller the extension. Okay. But this one you write terbalik cannot. The greater the spring constant. Yeah, the content is correct. But you cannot write terbalik. Okay. So this one normal. You need to be very, very careful. Okay. Other will be like quite okay. Small ball. Okay. Now I want to correct you one thing here. Now, what is small ball? Small ball, but I use steel. Big ball, but I use rubber. I use plastic. So this one must be heavy or light. or not? No, not necessary. Not like small ball, it must be heavier or lighter. No, not necessary. So you said small mass, then correct. You cannot say small ball, right? And then this one is the one that, oh, I should read the question for you. This one I give you the answer. State and explain the suggestion based on the characteristic of the spring and ball bearing and the method to aim the target. Method to aim the target is the one that I want. So this one you know, alright, this one all you know, alright. So method to aim the target. So now when you fire the ball bearing, this ball will go into this way. You go into this way. How? This ball, you go into this way, right? The ball will go to after it fire, you so it cannot forever straight because we got gravity. Your target is here, right? So you aim chun, but you hit here. Yeah, never get the target one. Never chun hit the target one. So you have to aim higher. Okay. The way to aim the target is aim slightly higher. Why? I give you the answer. I straight away give you the answer. Aim slightly higher. Why? Because of there is a gravity to pull it down. Kelantan 2020. Kelantan 2020. Kelantan. Question number 9. Question number 9. No, here. Okay. Now, question number 9. Here. I give you the whole thing, alright? I guess I have to give you the whole thing since I got this one already. Wait, I go into this way. I put it separately to save space. Here. 1, 2, 3, C2 until C2, B2 and until C2. Okay. Cut. Yeah. The answer here. Okay. And then D, I'll give the answer here. Here. Okay. Okay. So mark 1. In BM1. What to do? I don't translate for you. I guess you can. Right, BM1. So, dawai spring yang besar, right? Thick spring. So why? Elastic potential higher. Can store more energy. Right? Second one is elastic potential energy. No. High spring constant. Elastic potential besar. Right? High, more energy store. Right? The spring is elastic, so easy to compress. Right? Can compress easily. So the density of the ball bearing, it is low or low mass, right? Lighter. And then pistol dituju tinggi sedikit daripada sasaran, meaning that the ball, the pistol, it is aimed slightly higher, so the gravity will pull the ball bearing downward. Okay. So acted by the gravity. This is what we have. And I cannot give you all. Why I this year I am so rushed. I heard that your mock exam will be August. So this year, before Christmas, we are going to finish all the SPM paper. So your paper 3, SPM, will be like October to November. October like that. So I have to be very, very rushed. So now if you do, then you pass it up, then I will mark for you lah. Right, no worry. Like this one, I will mark for you. I will write the balik. I will write. If you really cannot do, then you ask me lah. Okay. This one should be okay for you. Um. Okay. Now this one, I slightly explain a little bit. The maximum force can be applied to the 450, right? But you apply 500, what happens? So the spring will break. No, it will get more than the elastic limit, so that it will not able to return back to the original size and shape, right? The force applied is more than elastic limit. The spring will break, not necessarily break, right? So it will like not cannot return back on the. Huh? Is that okay? So other is quite okay lah. Alright, I can see is quite okay. And then when you do this, make sure when you calculate, this one must be in meter, right? Cannot 5 cm. This one is in cm, 5 cm. Tidak boleh. Right? When you calculate energy, be very, very careful. Other will be okay. Other will be okay. Others are okay. Quite okay lah. Other like this one. So like this one, like what I told you, you got the same question. So the area under the graph is half fx for what kind of graph? Okay. I do explain to you just now already. So this one I'm not going to repeat. Now question. Alright. Should be okay for you. So this one I am gonna save it. Alright, you pass up and then I will mark for you. And then we are going to go for chapter 2 today. Before we go to chapter 2, we rest for like few minutes. Right, you go to rest for a little while before we continue. Okay. I'll be right back. So we are going to go for chapter 2 right now. When I change my title. Chapter chapter 2 sorry. Right. Okay. Now chapter 2, pressure. Alright, pressure. So we straight away go for pressure. So pressure is equivalent to the formula is F. Pressure is equals to F over A. So this one have to normal force. Right? Cannot just force. So normal force act on the unit area. So what does it mean by normal force? Normal force must be like this, 90 degree. 90 degree. Cannot like that. Right? The force, if like that, you have to resolute it. Right? Cos it or sin it to go for the 90 degree downward. Okay? That is the force applied. Okay? Now, the unit is, pressure is in Pascal. Right? This one, it is in Pascal. Right? Pascal, which is, it is Newton per meter square. Right? Newton per meter square. Right? Newton per meter square. So, force is in Newton. Area, it is in meter. So, we look at one example. An object A and B have the same weight of 50 Newton. And then find the pressure exerted on the ground. Hence, relate the pressure and area. Okay. Now, so for this one, right? For object A, pressure is equals to force over area. Force over area. Right? Pressure is equivalent to force. Right? Force is 50 Newton. Area, you look at the area. Area is 5 cm times 20 cm. So we are going to use in meter. Right? So this one is 5 cm. This is 20. 5 times 20. So now, because of this one, if you change it to meter, it's supposed to be 550 divided by 0.05. You divide by 100. 1, 2 decimal. And then time, you move 2 decimal, 0.2. So how much will we get? So 50 divided by 0.05 divided by 0.2. So you will get 5,000. Right? You will get 5,000. You get 5,000. So here, what I do is, I don't want to do it like move 2 decimal here and 2 decimal here. So I time 10 to the power of negative 4. Why times 10 to the negative 4? Alright. Like what I told you, this one you move 2 decimal, right? Negative 2. This one you also move 2 decimal. So altogether you move 4 decimal. So area of cm square. So you have to time 10 to the negative 4 if you divide. Right? Time 10 to the negative 4. Alright. So I try whether it is same as 5,000 or not. Alright. See. 50 divided by 5 divided by 20 exponent negative 4. Okay. So you have to write 20 exponent negative 4. Right. You cannot write time here, time 10 to the no. You just write exponent negative 4. So you will get this answer. Right. 5,000. Pressure is equal to 5,000 Newton. Sorry. Newton per meter square. So we call it as Pascal. Okay. Right. So we do this object B. Pressure is equal to force over area. Force over the area. Force. Force is 50. Same thing, 50 Newton. Area. You look at the area under the ground here. It is 10 times 5. 10 times 5, it is 50. Right? 10 times 5 exponent -4. Right? So how much will you get? 50 divided by 10 divided by 5 exponent -4. It is equivalent to 10,000 Pascal. So you also can write 10 kilopascal, but for me easier to see. So for now I don't want to use kilo first unless I use both kilo. Okay one, right? No problem. Okay. Now I have found the pressure, and then they ask you hence you have to use the answer here. So you see the area here, it is big. Area here, it is big. Now area here, it is small. Right? Area here, it is small. You see the area here, it is big. 5 times 20. The area here, it is small. So relate the pressure and area. Right? The bigger the area, the smaller the pressure. Right? When the area increase, pressure decrease. Right? The higher the area, the bigger the area, the smaller the pressure. So why? Okay, we look at the formula. Pressure is equal to force over area. Okay, I time the area upward. Area times pressure is equal to my force. So this force and this force, it is the same. So force, it is the same. So when this one times this one, they time together. When area big, pressure is small. Okay, so I want you to add in, right? If the force applied is the same. Okay, force applied, it is the same for this case, right? Force applied, it is the same. Area big, pressure small. Area small, pressure high. Okay, now if you understand this, so we are going to see what is the application of the pressure in our daily life. For example, scissor, knife, handsaw, all these are because of pressure, right? Why? When the area here is small, right? Here it is sharp. Here, this part, it is sharp. So area here small. So pressure, it is high. Area here, area small, pressure high. So area here is small, pressure is high. When the area, surface area, it is small, so pressure high. This is the keyword, right? Right? If you want to cut, but this one, the area getting bigger, right? Mean the scissor, the end of here, it is sharp, right? It is blunt. When it is not sharp, so what happened? So you find it is kind of hard for you to cut. So meaning that the area big, pressure is small. So you need to use more force to cut it. Not hard for you to cut. Okay, in daily life. So this one, wooden plank, it is placed on the soft ground to prevent the wheelbarrow to sink down. So what's that mean? Now, we know the area here, it is small. So here it is heavy. So when you push the wheelbarrow in the muddy area, so the wheelbarrow, the wheel will sink, right? Will sink into the ground. Will sink into the ground, right? So you put the area here as a wooden plank here to increase the area, right? Area of the wooden plank, it is big, so pressure will be reduced, so it will not sink to the ground easily. So now in the daily life, we got the lorry, got the truck, heavy truck. So heavy truck, the load, it is big. So now increase the surface area, right? Increase the surface area, right? pressure is equal to force over area, time it up. Area times force, pressure is equal to my force. Area big, pressure small. So it increase the surface area to reduce the pressure. So the rod will not be damaged by the truck easily. Okay, so you more tire, more wheel, more tire, so it can reduce the pressure. Now we see first example here. Now explain why the mattress sink if you stand on it, right? Compared to you lie on it. You lie. Why does the mattress sink when I stand on it? When compared to I lie on it, right? So when you stand on the mattress, right? When you stand on the mattress, the contact area here is so small, right? Area is small, right? So pressure is high, right? When you lie on it, so the area here is big, so pressure is small, right? So when stand on the mattress, the contact area between the leg and the mattress is small, so the pressure exerted onto the mattress is high, so the mattress will sink down. Sink down more. I mean, sink down. This one also sink down. This one also sink down. So this one sink down more. All right, sink down more. All right. Okay, I hope you can understand. So we try to see one more example. Explain the high heel. You are wearing the high heel here, and then you are wearing the sport shoe here. So the high heel, you sink down. You during the sport day, so you are wearing the high heel, you want to run, cannot, you will sink down. So why? You see the area here, area of contact, so little. So here, the contact area, it is more. Okay, so same thing, right? Why the high heel sink more? Because the high heels contact area with the ground is small, so the pressure exerted onto the ground is big, so you will sink down. Can you understand here? Okay, now this one you will not find in your book, your textbook, but in the exam they will ask you, right? This one I add in on my own. This one, right? Pressure is force over area, right? This one. So your 2.1 straight away go for liquid pressure. Okay, liquid pressure. So we are going to focus into the liquid pressure, and liquid pressure is, right? Pressure is equals to, right? This one is rho. Rho is density, right? This one is density. Density. Rho. Okay. Pressure E. So I didn't put in, no? I put in here, right? Rho is density, right? So the unit, it is kg. Unit, kgm minus 3. Where the density here, density, you need to know the density's formula is equals to mass over volume, right? Mass in kg, volume is meter cube, right? Kg per meter cube, right? Kg per meter cube, right? Mass over volume. Okay. Now the next thing is, right? Pressure, right, is in Pascal. G is gravity, 9.81, and depth of liquid is in meter. What is depth? Now, a lot of students, they are not sure what is depth. So, the depth is how deep from the surface of the water to where do you want to measure, right? This is called depth. Not from the bottom to top. This is not called depth. No. This is not called depth. This one is from the surface to how deep it is. This depth of water. Now, this one, it is not important, but I want to show you how do you get this formula. All right, pressure is force over area, density is mass over volume. So how do you get the formula of pressure in the liquid, rho GH? So I am going to make the formula, right? So pressure is equals to force over area. Okay, and now we know what is area. What is area? All right. So now here, area is here, right? This is called area. So what is volume? Volume is area time how high it is, right? Volume is A times H. Okay, right? We know that volume is A times H. Okay, now volume is equals to area times height. Okay, this is what we have. Now we got that density is equals to mass over volume. I copy this one down. Copy. Right? Density is equals to mass over volume. So now what is volume? What is volume? Area times height, right? Okay. So we put it in from here. Density is equals to mass divided by area times height. Okay, area times height. Okay, now okay, I put it to here. So this one I leave it as like 1. This one I leave it as 2. Okay. Now, from here, we know that what is pressure? Pressure is equals to force divided by area. Okay. So force divided by area. So here I need area. Area go up, density go down. Okay. So here I change a bit. This one don't want. So area go up. Mass still here, right? Density go down. H go down, right? Okay. Area. So I can substitute 2 into here, right? So substitute 2 into 1. Sub 2 into 1. So what do we have? Right? So pressure is equivalent to right? Force over area. Force, yeah. Force. What is force? Force, we know that it is mg, right? Right? Mg, yeah. So now this one is over the area. Area here is m over rho h. M over rho h. So when we got this one, so to make it easy, so I am going to put it mg, right, time. Because of this one is divide, you terbalik, alright. So rho is at the top. And then m is at the bottom. So I can cancel the m. I can cancel the m, right? I can cancel the m. So after I cancel the m, it is gravity times rho times h, right? gravity time rho time h. But me personally, I like to write rho gh, rho gh. But anyhow, if you like to g h rho g, up to you. Right? So because of they are timing each other, so no effect if you change the sequence of g rho h rho g. Right? No, nothing wrong. Okay, so this is how I prove it. So when you see they ask liquid pressure, you use rho gh. Okay. Now, for example, right, we try to look at one example here. So find the water pressure at point A, right? Pressure at point A and point B, right? What is the pressure at here, right? So in meter of water in Pascal. Okay. So A, we are going to do A. Pressure is equal to rho gh. Rho, density. So they will give you density. They will give you density of water. Density of water for fresh water, it is like 1000. If sea water, so it is like 1030 to 1050. So it's about still salt water still like 1000. So normally if they don't give you, you will take it as 1000. Right? So 1000 density of water. G, it is 9.81. H, how deep it is. How deep? Must be in meter. Right? So this one is this 10. Right? So now 1000 times 9.81 times 10. So you will get it as 98100 Pascal. Okay, 98100 Pascal. Oh, sorry. This one, it is in meter of water. I'm sorry. This one's supposed to be B. Hey, wait. They want answer in this way. Hey, how? Wait. Okay. I redo. Pressure is 10 meter water. That's all. I repeat. Okay. They want in meter of water. How many meter down? Alright. You measure in meter. So 10 meter of water. So if you want to change it to Pascal, you must use rho gh, this formula. You want to change it to Pascal, you must use, I repeat one more time because of it is important, you must use rho gh. Okay? Now, it can be many ways to measure it. It can meter of water. It can in mercury. Maybe some of you already learned it, right? You can have like a pressure is like 76 cm of mercury. You can use this way to measure it. You can use 1 atm, 1 atmosphere, but this one it is not using in SPM, so you don't need to worry this. Okay, so you can use Pascal, 10,000 Pascal, like that. You can use Pascal to measure it. So 10 meter of water. So B, pressure is equals to 20 meter water. 20 meter of water also can. 20 meter water also can. No worry. So now here they ask you B, change it to Pascal. Alright, you change it to Pascal. Pressure is rho gh. Rho 1000. G 9.81. H 20. Right. So H20. Here, right? So this one is 10. So I just times 2. Right, times 2. I get 196200. unit Pascal, right? If you think the number is too big, so you can change it to kilopascal, or this way, standard form, 1.962 times 10 of 1, 2, 3, 4, 5 Pascal, right? Also can, no worry, can one. Okay, so this is what we have, right? Now relate the depth of water with water pressure. Okay, so now the deeper the water, the greater the pressure. The water pressure. When you go deeper, so the pressure will be higher, right? So the deeper the water, the higher the pressure, right? So this is what we have. So we continue from here. Now this is 60 cm. This is 60 cm also, but this one is water. This one is oil, right? Find the liquid pressure, right? Water pressure and oil pressure. Okay, given the density of the oil, water, density of water, right? Water is 1000, like what I told you. Density of oil is 800. Give me 1 minute. I go and change it. If not, later I forget. Okay. Density of water. Okay, save. Alright, sorry. Okay. Density of water is 1000. Density of the oil is this. So relate, this one relate letter. So what we have is water pressure A. Right. Pressure is equals to, right? They want this one. They gave you the density, so you have to put in Pascal. So you are going to use rho GH. Rho density 1000, G 9.81, H 60. You answer wrong. So what's wrong with this? When you calculate pressure in Pascal, this one cannot be in meter. Cannot be in cm. Must use meter. So this one had to divide it by 100. Remember, this one have to divide by 100 to change it to meter. Okay. So now 1000 times 9.81 times 0.6. Right? You get 5 at 6. 5 unit Pascal. Okay. So when B is pressure is equal to rho GH. Rho, right? Rho of the oil is 800. It is lesser, right? Lighter, not lighter, lower density, right? Lower density. G is 9.81, still the same. H is same, 60. So this one I change it to 800 times 9.81 times 0.6. So what do I get? I get 4708.8. Pascal. Okay. Now relate the density. Okay, so we look at the formula first. Pressure is equal to rho GH. We know that. Okay. Now pressure, I don't know. Right? This one, height, the depth The depth 60, 60, same. Gravity, you acted by gravity, the same. So the higher the density, the higher the pressure. This one, density 1000, the pressure 5000. Right? Density at 100, this one 4000. So the higher the density, the higher the pressure. Right? The greater the density, the greater the density of the liquid, the higher the pressure, or the greater the pressure. Now, any question from here? All right. I hope it is okay for you. Now, factor the affect the liquid pressure. So now you do one experiment. Now, we are going to see the inference first. Inference is the pressure in the liquid depends on the depth, how deep it is. So the hypothesis is the deeper the water, right, the higher the pressure. Right, the deeper the liquid, right, the deeper the depth, the higher the pressure. So you are going to study how deep it is and how much is the pressure. So this one, the procedure is you prepare this one, all right, with the YouTube. All right, this is called YouTube. All right, not YouTube, not YouTube. It is like you punya tube, YouTube. All right, YouTube, Okay, so you immerse the tester funnel. This is the tester funnel. You immerse into the liquid 4 cm. Right? You record this D. Right? You record this D. This D represent the pressure. Right? The difference of here to here. You go deeper, then at cm, 12 cm, 16 cm, 20 cm. You see, you find it. This D will getting higher and getting higher and getting higher. Right, so this is the difference in pressure. Right, so for this one 4 cm, maybe this is 5, 10, 15, 20, 25 like that. Okay, maybe lah. You do the experiment, you find the difference there. Okay, what can you draw from this experiment? You will see that, right, the greater the depth, pressure is equal to rho GH. The higher the depth, the higher the D. D is represent the pressure, right? The higher the pressure. Okay. Now, the greater the depth, the greater the pressure. So this is what we have. What conclusion can you make? Right? The greater the depth, the greater the pressure. Right? This is what we have. Okay, now what is the relationship between water pressure and the depth? Okay. Okay. This one should be the answer here. Right. This one I cannot do. Actually, this one why I cannot do? Because of you need to draw the graph. You draw the graph. So what is the relationship? So normally, if you don't draw graph, you can answer in this way. But after you draw the graph, this one they ask you to draw the graph, plot the graph. So you plot the graph. D is pressure. As I told you, this is H. You find it? It is like that. So what is the relationship? So you can see it is linearly or directly. So this one is directly proportional. This one is directly proportional. But if you don't have the graph, you just say the greater the depth, the greater the pressure. Okay, so this one. So I will say the pressure is directly proportional right to the depth of water, right? Okay, now what conclusion can be made from this experiment? So you just said pressure is affected by depth of water. That's all. Right? So one precaution step in this experiment alright, make sure the tester funnel. Wait. Let me think. What is the precaution step? What is the precaution step? Okay, if you don't know, you just write. Make sure the eyes are perpendicular to the reading to avoid the parallax error. You always write this. This one is always correct because when you want to take reading, so you are going to write this. Okay. Make sure the eyes are perpendicular to the reading to avoid the parallax error. Alright, any question? Okay, I hope you're okay. Now, this one, it is the same. Now, inference is the pressure depend on the density. So we got this pressure is equals to rho GH. So you got two water and gasoline, right? You got higher density, lower density. So now the density different. So the pressure will be different also. Okay. Just now it is the depth. Now it is the density. Alright. So you do the same thing. You put in like alcohol, right? Like for example 10 cm, you see the density of the alcohol is how much, and then you see how much of this different. This one different, it is pressure, right? So you do this, then you get the answer. Alright. So what is the conclusion, Meg? So the pressure is affected by density. Right? Different density will give me different pressure. Why the method in let's try in page 42 is not suitable to study the relationship between the density of pressure in liquid? Let's try. Page 42. I don't have page. Why? This one, it is not suitable. Let's try. Let's try here. Okay. The effect of the depth of water pressure can be studied by using the plastic bottle. So this one, and this one. So now after the bottle has been filled with water, the masking tape, it is removed. So you remove the masking tape, and then the water was spurts out to the distant some distance lah, right, with the different water pressure because of the depth. Okay, why? This experiment is not suitable. Wait, I did this experiment before for my student. And I go and look for it for you. You give me like few minutes. Where? I did it like. Oh, here. Okay. Okay. Here got cover. I use needle to poke a hole here. The water will not spurts up. I made another hole. I made another hole, third hole. Here got atmospheric pressure. This is water molecule. The water will not spurts out yet. So you need the pressure from here. So I open it up. Okay. So obvious, not so obvious, but you can see I guess. You can see this one, right? So now you find it, the lower it is, not the lower, sorry. The deeper, this is the depth, right? From the surface of water to here, when the H pressure is equal to rho GH, right? When the H increase, the pressure increase. Pressure increase means it can spurt up further. So this one, the H, it is less, right? H here, it is less, right? So it will not spurt up that far. So this one also spurred up actually here, but you cannot really see it, right? So little, because the pressure here, it is so little. Okay. Atmospheric here got help lah. Just now, when I covered it, this one haven't reached atmospheric pressure. I will teach atmospheric pressure later. So when I cover it, no particles from here to press it down. So the water will not spurt out. But once I open this, the atmospheric pressure press here to press the water out, right? Now my question is, why the distance of the water spurt out at different height are different, right? Why? Pressure is rho GH. H increase, pressure increase. Don't have sound, no? Squeeze it. Okay, so this is what I have. I send it to here. So if you are interested, no. Wait. I copy this one for you. If you are interested, you can go and watch it. But this one is in Mandarin version, right? I do it short video with my short video previously. Okay, so now they are asking you. Right? They said, why the method? Let's try here. You make 3 hole here. Lubang 1, lubang 2, lubang 3. Wait, I remove. Okay. You got 1 lubang, 2 lubang, 3 lubang. Why? Alright, this one, it is not suitable for this one, right? Because why? Right? To study between the density of the liquid. Why it is not suitable? Because why it is not suitable? Because of the density of the liquid are different, right? So for you want to test, so if you want, I want oil and water, okay, how to compare? All right, you do one and then shoo, and then you use oil, shoo. So this one is, I only can see how deep it is, then how far it is. right? So this one is I use one hole, right? So if you want, you use this way. You see how I do, right? This one you make one hole, and then same thing. This one you make one hole, right? This one, like for example, 60 cm. This one is 60 cm. Okay, this one is oil. This one is water. You find that pressure is equal to rho GH, right? So now H it is the same, right? Density higher for water, density is higher. So this one sh. This one sh. Okay, you find it. This one it is near. Density is higher, pressure is higher. So you find it this way. You make 3 hole, no use, because the density of oil and water are different. Okay. Why the mercury is not suitable in the liquid in the YouTube manometer? The density of the mercury is too high, right? Very, very high. This one we are going to learn it soon, very, very soon. Not now, soon. Okay. Okay. So let me finish this one. All right. Example here. Now it is important. Don't leave first. This one is very, very important. Find the pressure at the point A and point B. Teacher, 10, 20. Right. So density, yeah, we got it. Okay, never mind. A pressure is equal to, right? Pressure is equal to 10 plus 10, right? So it is equal to 20 meter water. Okay. Now, of course, you ask me, Jagu, just now same leh. Why you add in 10? Okay. Now here, exactly the same. Even this picture and that picture, it is exactly the same, right? Now, here, I don't give you atmospheric pressure. Meaning that here got atmospheric pressure or not? Got atmospheric pressure. But I don't give you. I just want water punya pressure. This one pressure here only. 10 meter of water. Okay? Pressure here only. How much? Water punya pressure? 10 meter. Right? Now, see this example exactly the same. I never said find water pressure. No, I said find the pressure, total pressure at point A and point B. Right, point A here. What is the pressure at here? So here got atmospheric. How do you know? The question give you. How much? 10 meter. Here, 10 meter. So the atmospheric pressure they give you in meter of water. So you use 10. Right? And then this one, another 10 is because of water. This one is atmospheric. This one is water, right? So it is 20 meter of water. 20 meter of water, you want to change it to Pascal. So pressure is equal to rho GH. So rho GH, rho, density 1000, G 9.81, H it is 20 here, 20, must be in meter. So how much will you get? I straight away use the answer here faster. Pascal. Okay. Why? Because here got atmospheric pressure. So I will add in here P. Normally atmospheric pressure, I will write ATM. Right? ATM machine. Atmospheric. I'll write it into this way. So easier for you to see. How much? 10. Here 10. Here 10. So altogether 20. Find pressure at point A. Now I go back again. Here. Find water punya pressure. Find water only. Atmospheric tidak tahu. Don't give you. No. So find water caused by the water. Pressure caused by the water. 10 meter. Find pressure at point A. So you need atmospheric and this. You need this and you need this. But in the exam next week, you'll see lah. Sometime they will give you this way. Find water pressure at point A. And then they give you PATM. Yeah. Then how? They said find water pressure. So you need to add in. I see many times, right? The marker, the exam, they give you this, mean they want you to add in. I think most of them are putting water in because of they don't understand or they got error, right? They accidentally put it in. So you need to see, right? Water pressure or pressure. All right. Next week you'll see. Next week you'll see. Today not enough time to see it. So now B. What is the find the pressure at point B? All right. Pressure at point B is 10 plus 20. All right. It is 30. How 20? 10 plus 20. 10 is atmospheric pressure. 10. So 20. All right. 10 plus 20. It is 30. So now I want to change it to Pascal. Pressure is equal to, you want to change it to Pascal, you need to use rho GH. Rho GH, right? Rho, you know rho is 1000. G is 9.81. H it is 30, right? Must be in meter. So, rho GH, I put it in, I'll get 2943. Unit Pascal. Unit Pascal. Okay, so give me one more, right? I want to do this. Now, find the pressure in A. Find the pressure in B. Okay, right? Pressure in A. Pressure in A is equals to, now pressure, not water pressure. Pressure is, you need atmospheric pressure. Atmospheric pressure is 10 meter water plus, right, 0.6 meter water, right? 10 meter water plus 0.6 meter water altogether is 10.6 meter water, right? But we normally will not leave it into this way. We are going to change it to Pascal, right? So Pascal, we are going to use rho GH, right? Rho GH. Rho is 1000 for water. G is 9.81. And H is this here, 10.6. So we try to calculate 1000 times 9.81 times 10.6. How much will we get? 103986. 103986. Unit Pascal. Pressure at point A. Now go back to what we have just now. Right here, we look at this one just now. Find the water punya pressure. Find water punya, not find the pressure here. No. So this one no atmospheric pressure given. Right? Find water punya pressure. So water only, rho GH. Alright. Now come back to here. This question. This question slightly harder. Pressure at point B. Pressure at point B is, right, 10 meter water plus 0.6 meter of oil. So 10 plus 0.6, 10.6. Cannot. This is water. This is oil. Cannot do. This kind of question cannot do. So what do I do is, this one, I want to change it to Pascal first. Right? So now, this one is rho GH. Plus here, rho GH. Rho GH of water in Pascal, same unit. Right? As this one. Rho GH of oil, right? Same unit. You teacher, this one you plus because of they both are water. You can plus, but this one is not both water, so you cannot. So now rho is 1000. No. Rho water this is water 1000. G is 9.81. H is 10 meter, right? Plus here rho of the oil 800. G 9.81. H it is 0.6. So we press in the calculator. 1000 times 9.81 times 10 plus 800 times 9.81 times 0.6. Okay, so we got this. You got this. Okay, got this. So answer is 10280 10280.8. Okay, we just copy 10280.8 unit Pascal. Okay, see again, if this one same unit, okay, you can plus it directly. If the unit here and unit here, it is different, so you have to change to both same unit Pascal. Change it to Pascal, then you can plus them. If not, you cannot. You will never plus them. All right. This one I know. We are going to do it next week. Okay. If you can, never mind. You try to do this as homework. Wait, this one as homework. Question number 9. Page 9. Page 9 as homework. Page 9 homework. Okay. And then the last thing before I end the class, I need to tell you. Now I have sent your tuition fee that you need to pay for next month into the group already, so you can pay accordingly. And then you go and check your referral. If your referral here it is wrong, for example, like where I need to tell you so your referral is wrong. Like for example, Eden, your referral is wrong. He PM me already. Teacher, my number is wrong. So I'll modify for you. Right? I'll modify for you. Tuition fee will be 65 every month. Registration fee 20. You have to pay one. Right? And then 50 for material. You have to pay one. So first month you only pay 135. Right? If you next month, right? Next month, it is 65. Next month, it is 65. Next month, it is all 65. No more. This one pay one time only. Right? And then the account number, it is here, so you can put it in. Right? After you bank in, you screenshot to me. Right? If you screenshot to another number, right? That one is PTSC admin. She is not working for me already, and then that number I take it back, and then my kid is taking that number, so my kids will tell me when he saw the message, so it will be slower. All right. You PM me will be faster lah. If you can, you PM me. You PM me the screenshot. Okay, I am going to stop here. Okay, if any question, you PM me. All right, I'm going to stop here. I'll see you again next week. Bye bye. Bye bye. You can click the link at the chat box there to see my video, but it is in Mandarin. Alright, bye bye. I'll see you again.